So everybody, cosine x sine is y. Now here's what's important. So you filled out unit circle. Once again, just a reminder of a couple of things, everyone. Looking up here, remember that we are all ready to go. This is the positive angle this way, right? This is the negative angle. So if it says sine, find the sine at negative 2 pi thirds. That's literally saying find the y value at negative 2 pi thirds. You've got to go in the negative direction. So positive 2 pi thirds is up 1, 2, 3, 4, 5, right? We've got to do that in the negative direction. Down 1, 2, 3, 4, 5. Right there, right? So the sine is our y value. So our answer is negative root 3 over 2. Raise your hand if you got it right. So Lot did. Awesome. And then cosine is x. So it says the cosine at 270. That means find the x value at 270. Positive 270 is there. So our answer was 0. Very good. A lot of you got it right. A lot of you got points. Some of you didn't. That's okay. All right, moving on. So what we're going to do today is we're going to first learn how to fill out a unit circle. We're going to have a quiz next time. You have to be able to fill out a blank unit circle on the test from scratch. Luckily, I'll teach you a trick, and it's way easier than it looks. It's way easier than it looks. So everybody, the first thing I do when I fill out my unit circle is I fill in the outside. So this is where I start. I say, okay, this is, first of all, the unit circle has a radius of 1. So if I literally here's my origin. I'm going to this point. This is an XY point on my graph. That's going over 1 up 0 on x. Correct, everybody? Does everybody see? So then this would be going negative 1 up 0. Think about it. Literally, if you were going to graph a point, that's going negative 1 up 0. Up here is over 0, but up 1. Over 0, up 1. So I fill in these first. Over 0, down 1. Questions? Then from there. What do we do when we walk in every day? Finder. Okay, so a couple things. This is just something you have to memorize, a little trick. So we're going to fill out this top half quadrant 1 first. You're going to think of this as the square root of 0 over 2, which is just 0, right? Then this will be the square root of, counts up, square root of 1 over 2. So then this is the square root of 2 over 2. Square root of 3 over 2. So that puts me here at the square root of 4 over 2, which makes sense. Look, square root of 4 is 2. 2 divided by 2 is 1. So we ended up in the correct spot. Then you'll just do that the other way. So this is square root of 0 over 2. This is going to be square root of 1 over 2. This will be square root of 2 over 2. Square root of 3 over 2. And then look, square root of 4 over 2, which simplifies to be 1. Now, any questions on that? That's just a little method you're going to have to memorize. So this is the square root of 0 over 2. Then it counts up. Square root of 1 over 2. Square root of 2 over 2. Square root of 3 over 2. Does that make sense? You just do it the other way. Okay, now I do want you to fix a few things because obviously the square root of 4 over 2 is just 1, so you don't need to write those down. I was just showing you. Square root of 1 over 2, square root of 1 is just 1. So instead of writing square root of 1 over 2, just write 1/2. So right here, square root of 1 over 2, just write 1/2 instead of, because that is the same thing. Now, look at this. So from here to here is the same distance as here to here. So this point and this point are going to be the same. So root 3 halves, 1/2. Everybody's following. Look, in the middle is going to be the same as this middle. So that's going to be root 2 over 2, root 2 over 2. This top one's going to be the same as that top one. So 1/2, root 3 over 2. Now think about those xy points. They fall right here. That's going from the origin, negative x, positive y, negative x, positive y, negative x, positive y. So you'll go and put in a negative for all your x's. That's it. Pretty easy, right? So once you know quadrant 1, you know the rest. So look, this distance down is the same as that is up. Do you see what I'm saying from the x-axis? So then this will be the same as that point. So you'll write root 3 over 2, 1/2. The middle one is root 2 over 2, root 2 over 2. The bottom one will be the same as this one right here. So it's 1/2, root 3 over 2. Now you have to say, but those points are negative x, negative y's. So both are negative, both are negative, both are negative. So it's really easy. Once you know quadrant 1, you know all of them. So then right here, we would fill out this the same as this. So from here to here is the same distance as here down to here, so this will be the same point. And then 1/2, and then √3/2. And then that's positive x, negative y's. So all your y's will be negative right here. Okay, so I'm going to bring around another blank unit circle, and then we'll fill out the rest, but we're going to learn it in sections. We're going to memorize it in sections. So now I'm going to have you start on a scratch one again, and then make sure you can fill out the outside. We're going to spend the first, 25 minutes of class learning this. So I'm going to give you a blank one. I'll bring them around. Start over, fill on the outside. Everybody good? This is how I tend to do it. Okay, everybody listening. So now filling out the degrees. This is 0 degrees, obviously, right? And 360 degrees, correct? This is a fourth of the way around a circle, which is 90 degrees. Then halfway around a circle is 180 degrees. Then add another 90 would put me down here. 270 degrees. Now from here, if you know quadrant 1, it's easy to get the rest. So these come from special right triangles, 45, 45, or 30, 60, 90. So literally 30, and 60, and then 45. So 30, 45, 60. That's all you got to know. Now notice the pattern. We add 30, add 15, add 15, add 30. Do you see the pattern? Add 30, add 15, add 15, add 30. Add 30, which would be 90 plus 30, add 15, add 15, add 30, would put me at 180. So you're literally just, do you get what I'm saying? So 90 plus 30 is 210, right? Add 15 is 225, add 15. You're right, oh, that's funny. Sorry guys, last night hurt. Okay, so 90 plus 30, and then add 15, 135, add 15 is 150, add 30. Add 30, add 15, add 15, add 30. Add 30, okay, you guys get the picture, fill it in. Apparently, if you need a calculator like me, $210, $225, $240, $270. I was trying to think of.
Oh my God.
All good? Okay, now the next thing is converting from degrees to radians. And I've debated on how to teach this, but I think we should just make our life as easy as possible. Agreed? So how do we convert from a degree to a radian? You multiply by pi over 180, don't we? So let's rewrite, because this is 30 degrees. This right here is 30 degrees. But the radian measure is also important. That would be this physical distance. So then we'll convert degrees to radians. So you take your calculator, do 30 divided by 180. Math, enter, enter. You get 1/6. So that means this is pi 6. Everybody good?
Yeah.
Now let's convert 45 degrees. 45 degrees times pi over 180. So you literally take your calculator. 45 divided by 180. Math, enter, enter. 1/4. So this is pi 4. And let's convert that. Times by 60 times by pi over 180. So now you'll take your calculator. 60 divided by 180. Math, enter, enter. Pi 3rds. Pi 3rds. Now the other ones are these. There's some that are really easy. Like look, if this isn't a full circle 2 pi, everybody, let's fill out that quickly. Then isn't it halfway around pi, guys? Then wouldn't this be halfway between those? Wouldn't it be pi halves then? So there's 1 pi halves, 2 pi halves. Won't that put me at 3 pi halves down here? 3 pi halves. So you can make your life easier. And then some people can recognize. I can give you some more tricks, or you could just convert all of them. Do you prefer just converting to not confuse anyone? So that's a 3 pi half. So then you take your calculator and do 120 divided by 180, math, enter, enter. So that's 2 pi 3rds right here. So that's almost easiest, just to convert all of them. You all good?
Yeah.
Or I can give you other tricks, but I just think why complicate it? right? Why complicate it when it doesn't need to be complicated? So finish filling that one out. Then I'm going to bring around another blank unit circle. Fill it out from scratch. Start to finish, fill it out. That's what you're going to do next time on the quiz. And on the test, same thing. What? I just converted 120 degrees times by pi over 180. So you'll just take your calculator. Does that make sense? Just with all of them, we'll convert over. Some of you advanced thinkers probably could actually learn how to fill this out quicker. Like, ready? You ready? Ready? Are you listening? So from here to here, distance is 1 pi course. From here to here, right? So that was that much distance. It was like the big plus the little chunk. So a little plus a big would be the same amount of distance, right? So that's 1 pi force to there, 2 pi force, right? So wouldn't this chunk from here to here be 3 pi force? Like, you see what I'm saying? From here to here, so 3 pi force. Do you get what I'm saying? If not, just convert it. But then from here to here would be 4 pi force, which is pi. So then from here to here is that same distance, 5 pi force. So then it's a little bit quicker.
Yeah.
Oh, crap. So I should have told it like that. So, good. But maybe you're just an advanced thinker. So then, 6 pi force, which simplifies to that. Right here would be 7 pi force. Yeah. Okay. Yeah. So then right here, it's just, then it gets a little bit hairier. But right there is pi 6. So then from here to here is that same amount of distance. That would be 2 pi 6, which is pi thirds. 3 pi 6. Okay, awesome. Hey, so I'm going to come give you have. So if I said to you, go from degrees to radians, remember they are the same thing. One's just the degree it opens up on, and the other is the physical length of the arc. So let's switch from degrees to radians. So you'd say to yourself, I need to multiply by either 180 over pi or pi over 180. We need our degrees to cancel out though, don't we? So, well, if I put 180 on top, then that's not going to cancel out my degrees, right? So we're going to multiply by pi over 180 degrees. Now look, my degrees will cancel out. So then remember, when you multiply fractions, you multiply straight across. So we're really looking at 270 pi over 180, and then you would take your calculator, 270 divided by 180, 3 halves. So your answer in radians is 3 pi half radians, right? This is pi radians, and then there's the physical decimal radians, right? 3 times pi divided by 2. But I would want to leave it as this, probably. Okay, next one. Switch from radians to degrees. So we need our radians to cancel out, so we'd multiply by 180 over pi. Now look, by hand, in this one, our pi's divide out, right? So then multiply straight across. 3 times 180 divided by 4. 135 degrees. Everybody good? Okay. We also learned how to find the physical length of an arc. So, to find the length of an arc, you take the radius times theta, where theta must be in radians, not degrees, because otherwise our answer is going to be like a degree measure. We want the physical distance. So, if I said to you on the test, it's a good example. It says, what arc is longer? Now, these are not drawn to scale. That means they're just drawn. They're not drawn appropriate to size. So, which length of which arc is longer? So, let's do it. So, length of the arc is our radius, which is 8 inches, times theta, which is pi halves. Now, isn't that already in radians? So, we're good. We can literally write it as 4 pi inches. 8 divided by 2 is 4. Does everybody see why I got 4 pi? Now, I want to compare, so I want to actually multiply pi in. 4 pi is about 12.6 inches. So this distance from here to here is literally 12.6 inches long. Now let's do this one. So we're doing radius times theta. So S is equal to our radius, which is 7 inches times 92 degrees. Now we can't do that because we need it to be, our answer is going to be degrees, right? If we do that. So won't we just push pause for a second, go off to the side and say, I probably should convert this into radians instead of degrees. So you'd multiply by pi over 180. So that would be 92 divided by 180. 23 pi over 45. So S is equal to 7 inches times 23 pi over 45, right? So now you'll take your calculator, type in 7 times 23 divided by 45. 7 times 23 divided by 45. And you get 161 pi over 45. That would be the math answer, but we're comparing. And that was inches. So then type it in. Everyone do it. 16 times pi. Hit enter. Divided by 45. 11.2 inches. So now I know that that physical distance was 11.2 inches. So this one was longer. Yes. 7. So we multiply fractions straight across. 7, yeah. So 7 times 23. Good question. Divided by 45. And then does that make sense? Good question. Okay, cool. Awesome. No, that's good. All right, here is the lesson starting. So I need everyone focusing so I don't have to assign a buttload of homework. So, everybody, before we were all dealing with non-right triangles, we're able to find missing side lengths of non-right. I'm not going to teach if you're talking so hard for me to talk. So, we're able to find missing side lengths and find areas of right triangles in the past. Well, now we're in secondary 3, so we have to be able to find of any triangle. So just first of all, we're going to focus on how to find the area of a non-right triangle. But let's first remember how to find the area of a right triangle. So if we have a right angle, you can literally just use the formula for area of a triangle that has a right angle is 1/2 times base times height. So the area of this, that would be filling it in. Do we all know what area means? So then our area is going to be 1/2 times 2 centimeters times 4 centimeters. So that would be area is equal to how many square centimeters? H divided by 2 is 4. So that's 4, and then didn't we do a centimeter times a centimeter? So that's centimeter squared, which doesn't affect the 4 at all. It's just a units of measurement. Does that make sense, everyone? So basically our answer is 4. Do we all understand? So the area is 4. Well, look right here. It has a right angle in it. So we can find the area of this. Area is equal to 1/2 times base, 8 inches, times height, 7 inches. So what's the area? What is it? 28? Like, are we rounding? That's perfect. It is 28 inches squared. Okay, everybody good? So that's covering 28 square inches. Okay, awesome. Now look right here. If we were given a non-right triangle, so these had right angles, we can't use this formula. So here's the formula. You should be taking some notes here. You're going to need this formula. You're going to have it memorized. So area of a non-right triangle is this formula. Notice it looks very similar. It's 1/2 times side 1 times side 2 times by sine of the angle in between the two sides. So to find the area of a non-right triangle, you take one of the sides and the other side, and you have to have the angle in between those two sides. And if you do, you can find the area. So you would do 1/2 times one of the sides times the other side times by sine of the angle in between. It has to be the angle in between the two sides. Does everybody understand? Has to be. Can't be a different angle. Then that's all you do. Plug it in. We always have, now this formula will work for all triangles. So we could even use this formula for these type of triangles, as long as we knew the angle in between two of the given sides. So you see how this is a 90, this is a 2, and this is a 4? We could have used this formula. So look at my examples up here. I'm going to do 3 quick examples, and I'm going to let you just go for it on your paper. These aren't on your paper, though. So you're just watching. These are so easy, you don't need to take notes. It says find the area. You'd say, oh, that's a non-right triangle. So the formula for that is area is equal to 1/2 times side 1, which is 14 inches, times side 2, which is 11 inches, times by sine of the angle in between. Now you'll just type it into your calculator. Go, go, go. So the area that fills that in is what? Now your calculator needs to be in degree mode because you're typing in a degree measure right there. What is it? Right? So our area is 69.7 inches square inches. I thought that's what you guys said though. It's it's 7/8. Okay, so then so it probably is. People just don't speak up. Yeah. Okay, awesome. Good. Okay, so any questions on that? Pretty easy, right? So couldn't I find the area of this one? 1/2 times that times sine of 10. What about this? Yeah, because I have a side, the other side, and then an angle in between. Do I need to do more examples? Are you guys good? What if I gave you a statement, because it's almost too easy if I draw the picture for you. I'm going to on the test make it a goal to not draw the picture. It says, a triangle has side lengths of 15 inches, 22 inches, and the angle between is 95. Find the area. Isn't that easy? You just draw the freaking picture. Okay, awesome. Okay, what I'm going to have you do is problems. Flip to the back of your worksheet. Flip to the back. And you're going to do problems 28 through 33. Ready, set, go. Okay, so here's the formula. So everybody, a couple things to note. If we have a non-right triangle, we still... So, if we have a non-right triangle, we still have to be able to find missing angles and missing side lengths. So one of the ways we can find that is it's called the law of sines. There's no formula for the law of sines, right here. So it's sine of angle A over side A equals sine of angle B over side B will be equal to sine of angle C over side C. You don't have to set up all three at the same time. We always only ever set up two of them, but basically what the law of sine says is the sine of an angle divided by the side across from that angle will be equal to sine of the angle divided by the side across from it. So what I do need you guys to understand is push pause on writing the formula down and look up here. This is how they write angles. They write angles with capital letters. So this is angle A, angle B, angle C. Do you see how angle A is across from side A? And angle B is across from side B, which is written as a little b. And angle C is across from side C. Anyone confused? Okay, if that's true, then sine of this angle over that side will equal sine of this angle over that side, which will be equal to sine of this angle over that side. So these trig ratios will hold true. Now you can actually do the reciprocal, so write this down. We can reciprocate this and do side A over sine of A equals B over sine of B equals C over sine of C. These are the angles, sine of angle C, these are the sides. So if I said to you, find the missing side, and it was a right triangle, you just use right triangle trig. Just a reminder. So you would just use right triangle trig here. You would set up a trig ratio. Opposite and hypotenuse is sine. So you'd say sine of 30 degrees equals 5 over x, right? And then you'd solve for x. However, notice in this triangle, we're trying to find x, just like we were here, right? But do you see how it's a non-right triangle? We would use the law of sines in this case. And I'll show you how in a second. Now notice, if I gave you a right triangle, and I said find this angle, and I gave you two sides, let's say 10 and 8, because there's a right angle, couldn't we just set up a trig ratio with right triangle trig? We practiced that on day 1. Remember doing that? Opposite and hypotenuse, so you'd say sine of theta equals 8 over 10, and then couldn't you just take the inverse? You guys remember doing this? However, if you have a non-right triangle, we can't do that. Do you all understand? We'd have to use the law of sines. So write this down. This is when you use the law of sines over the law of cosines. We'll always use the law of sines over cosines if possible, because law of sines algebraically is actually way easier for the most part. So we use the law of sines when you have, just like in this example, when you have two angles, so boom, boom, and one given side, which the side has to be across from one of the given angles. So everybody look. See how I'm given two angles? And I'm given a side that's across from a given angle? We can use the law of sines. And once you see how the law of sines works, you'll be able to say, oh crap, the law of sines doesn't work in this case, so I must be using the law of cosines. So if you have two angles and a side where the side is across from one of the given angles, then you will use the law of sines to solve for missing sides. Now, can't I find this angle really easily? 180 minus 40 minus 30. If necessary, I could find that angle. Okay. Awesome. Now, also, we use the law of sines when you have two sides. So, look, side 8, side 10. When you have two sides and you're given an angle where the given angle is across from one of the given sides. So this time we're given, instead of two angles and a side, we're given two sides and an angle where the angle is across from one of the given sides. Everybody good? Then I'll show you how this works. Are you confused? A wee bit, maybe? Okay, well, I'm sure it's confusing until you see an example. Okay, did you write down when you can use the law sign? Okay. Ready for the first example? Okay, draw this picture in your notes. So notice what I'm being asked in this one. Everyone's focusing. I'm asking you to find an angle, but we can't use right triangle trig because this is a non-right triangle. So Pythagorean theorem doesn't work and right triangle trig does not work. You all understand? You'd say to yourself, okay, I'm given an angle. Look, I'm given an angle. Oops. I'm giving an angle and I'm giving two sides where a side across is let me say that one more time. Holy cow. I'm given one angle and two sides where a side across is across from the given, like this and this are across from each other. Do you get what I'm saying? I can't say that correctly. All good? So then we say, okay, we're trying to solve for x. Now that's an angle x. So that's going to go in, the rule is sine of the angle, so sine of this angle, so sine of x degrees, over the side across from it, ding, 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 over 10, will be equal to sine of the angle, so let's use 18. So sine of 18 degrees over the side across from that, so over 12. So everybody see how I set up a true statement? And now it's just algebra to get x alone. Any questions on how I set up the problem though? That's what the law of sine says is true. Sine of an angle divided by the side across equals sine of the angle divided by the sine across. Does everybody get it? So now let's use algebra to solve for x. What's my first step? Good. Multiply both sides by 10. Good that we have some people that are really good at algebra back there. So then we have sine of x degrees equals 10 sine of 18 all over 12. Now you're saying to yourself, I'm trying to solve for x, but it's trapped inside sine. How do we get sine alone? X alone. Yeah, we can't divide by sine, but we can do what? To undo sine. Sine inverse. So we're going to sine inverse both sides of the equation. So now on this side, sine inverse undoes sine. So x drops out. So x degrees equals. And over here it was sine of all that stuff. Sine inverse, of all that stuff. So 10 sine of 18. And so it's just algebra. Once you set up a true statement, it's just algebra. So now you literally type it into your calculator. Ready? I want you all to do it. Second sine of all that stuff. Because if we don't know how to type in right, I need to come help you, which is great. That's why we're here. $14.9?
Yep, no domain.
So you just typed it in wrong. Second sine inverse. You forgot to type it in. You didn't type it in right. Did you type it in? Type it in. Cool, so this angle is 14.9 degrees, which is great. Okay, so now we can continue, if I asked you to on the test, to continue solving. Couldn't you find that angle? 180 minus that, and we can keep solving. Okay, let's do this example. It's different. The algebra comes out different, and I'm going to let you go for it in just a second. So we have this picture. It's a non-right triangle. You're saying to yourself, I'm trying to find this missing side, but it's a non-right triangle, so I can't use Pythagorean theorem. I can't use right triangle trig, so let's use the law of sines. Because here's why. We're given two angles and one side, so then we can set up the law of sines. So now I always put what I'm trying to find on top. So isn't that x? So it'd be the side divided by sine of the angle across. So x over sine of 31 equals, you guys see how those go hand in hand? Equals, now we're putting this on, we're switching this trig ratio. So we have to put 21 on top. We did the side on top. So 21 over sine of 43 degrees. That's degrees. And now we'll just use algebra to solve for x. Is anyone confused? Okay. So what do we multiply both sides by sine of 31? So those divide out. So we have x is equal to 21 sine of 31 divided by sine of 43. Type it in. So side x equals 15.9. Now look and see if your triangle makes sense. This angle is smaller than this angle. So shouldn't this side be smaller than this side? Yep, all is well. Now, couldn't we go through and continue solving? Because couldn't we do 180 minus that to get that? And then couldn't we set up the law of sines to find that now? Does that make sense, everyone? Okay. Do you need more examples of those types? Actually, yes, you do. On your whiteboards, do both, 7 and 8. Good point. So are you all running into a problem on 7? Do we know? So we're trying to find x. So this is when we would say we can't use the law of sines. So if you didn't run into a problem, you've done it wrong. So you'd say sine of x over the side across from it. Yikes. Do we know the side across? No. So we cannot use the law of sines to solve this one. So we can solve this one using the law of cosines, which we're going to learn next time. Does that make sense? So you can't solve that one with the law of sines. So go on to 8. Go on to 8. And you can do that one. This one is harder than the area one. So look. It says, in triangle GHJ, this is the last example, stick with me for one last one. In triangle GHJ, angle J is 39 degrees, side H is 36, and J is 42. Find angle H. You have to draw it correctly or else you are going to get it wrong. So you would draw a triangle. It doesn't need to be drawn to scale. So let's go GHJ. Why not, right? So angle J is 39 degrees, so I got to put it there. It says side J is 42, so that needs to go right here, doesn't it? And then side H is 36, and now it says find angle H, so this is what we're trying to find, right? So what did we do? Sine of question mark over 36 equals sine of 39 over 42, right? And then we just solve. Everybody good? Okay, show me you can do it on the homework. This is what's going to be done, checked off with me in class before you leave today. Good deal? Every single one of those is solvable by the law of sines. Every single one.